So, oh, well, I must congratulate you. That's a really nice base, that is.
Thank you, Wayne. Yeah, I'm preparing for a bit of an art exhibition.
Oh, wow.
Yeah, I started at a shamisen and I added a string, drew a bass, and I added another string, 5-string, keep going.
What's the eventual?
I'm going to get to a sitar.
A sitar?
Yeah,
Wow.
yeah.
Wouldn't sit on it.
No, I wouldn't.
So is this for the Tate Modern then?
No, it's for the Tate Prehistoric.
Oh,
yeah.
wow. Revolutionary. What we do best, eh?
Yeah. Bit of culture for you on the... if you can call it culture on the floor again.
Yeah. You love chemistry.
Yeah, so...
Speaking of bases though...
Yeah.
Bass.
Bass. That was smooth.
Nice.
Well done.
So we've done acids and the strong and weak acids and working out the pH from just looking at the concentrations.
So now we're going to do the same thing with bases.
Yeah. We're only going to deal with strong bases because weak bases are weird.
So yeah, we'll just leave them alone, I think.
I think we will. So a strong base, just like a strong acid, it's something that fully dissociates. So it's typically hydroxide. I'm going to go with potassium hydroxide, but you could have sodium hydroxide you're probably more familiar with.
Yeah.
But that just makes it less likely to come off because they like to slightly
change
things you don't know.
Yeah. And it says plus AQ, you're just putting it into water there.
Yeah. So to be strong, it fully dissociates into K plus OH minus, just like HCl, a strong acid, splits into H plus and Cl minus. Same thing. So it's completely dissociating, is what you would say.
Yeah, and then they'll ask, why the pH, please?
So the question is to find the pH.
That's what we're going to start with. So you remember when we went back when we did acids, we had to use an assumption to do this.
The same assumption can be said for strong bases.
It can be.
And that assumption is that this concentration of the original thing, this strong base, is equal to the concentration of one of the products. So OH minus is the useful one to use out of this.
Yeah.
So we can use that assumption.
Now, but that's not all we need, is it, Wayne? We need one more thing.
We need, you know, I'd remember it if I were you, but you're often given it in the question.
Yeah.
The KW value, so the ionic product thingy.
Yeah.
Ionization of water.
That one.
At 25 degrees Celsius, it's the only one you're asked about. It's
Yeah.
1 times 10 to the minus 14. That's the number you have to remember.
Why is that equal? Why is that equal? Why is that useful, I hear you ask? Very, very loudly, so I misheard what you said. Well, remember our KW is equal to our H plus...
Yep, times our OH minus, and that was done in the previous video. So it's equal to that, and you might be thinking, well, why is that useful? Because H plus isn't in this equation.
Well, it is in the actual experimental equation.
Yes.
Because you're in water, and there's H plus ions floating around in that.
And you may well remember, and hopefully you do, that pH, the thing that we're trying to work out eventually, is minus log of the H plus.
It does indeed.
So we're going to need H plus in order to work out the pH. We can use this equation to do that.
We can. So if we have a few values, we don't yet know what our concentration actually is.
We do not. In the question, it would tell you the concentration of your initial base.
Yeah. So say it's 0.05.
Yeah. I'll put that here.
All right.
0.05. So that is the concentration of the original base.
So we did a bit of rearranging of this equation.
Yeah. So we can rearrange this to find H plus by doing KW divided by OH minus.
Yeah, which now has a value.
It does. Using the assumption that this is equal to this, we can say that the OH minus is the same concentration as the KOH, which was given to us in the question.
You also know
0.05.
This value.
1 times 10 to the minus 14.
And that will give us a value.
2 times 10 to the minus 13.
Yes,
we can do this one just by thinking about it. But we're not done. That's found as a concentration of H+, so we can now do the next step.
We can.
So this we will need a calculator for because I'm not
You write it. I'll put it in.
So pH equals minus log to the base 10, which is just the log button, of your H+. We'll just work that out to be 2 times 10 to the minus 13. And that will give you a value for pH.
Which is 12.7 to one decimal place.
12.7. So there we go. We've answered the question. We've found the pH. It is 12.7.
Great success.
Excellent.
This, however, isn't the only method of doing it.
There's a second method. Now this method I find easier, however it does require some mathematical knowledge to know how it works.
It does, we leave the top thing up.
Yeah.
So here we're talking about pH, and we don't know an H value of anything. No. You also talk about POH.
Yes. Slightly different approach, And the reason it works is slightly more mathematical.
Yes.
We'll get to that in a minute.
We'll get to that in a minute, but it's a similar thing to this. Remember, pH is minus log of our H+,
Yep.
so this will be the minus log.
Of our OH minus.
Absolutely.
So that will give us the POH,
Yeah,
but we
so-
want pH.
But we can put that, we can work out what that is, because we know the things, and that is something.
Yeah, minus log of 0.05 gives you something, which will give us our POH.
Mm-hmm.
And then there's a final step.
And that gives us 1.3, and if you 14 minus that,
Yep, this is always the same. You do 14 minus the minus log of OH minus.
yeah, and that gives us 12.7, which
Same
is
answer.
same answer.
Look at that, 2 lines, much simpler, but you're probably thinking, you know, why does that work? Where have you got that from?
Yeah.
If you're not, then that's fine. You can just
that-
go and apply that, and that's a simpler way of doing it.
If the maths, if you, what I was thinking you'll have worked out what we're doing, is a few bit more steps if you did explain it fully.
Yes, so let's do that, because some
Right.
people learn better when they understand why it works, as opposed to just
Yeah,
plonking it
just
in
having a
and
formula that's quick.
doing that. So we've got this KW equals H plus times OH minus.
Mm-hmm.
So let's rewrite that. The other way round, we've got H plus times OH minus equals KW, which
Yeah.
is 10 to the minus 14.
Which is the same as 1 times 10.
Yeah, 1 times 10 to the minus 14 is the same.
Yeah.
So we can do that. Now, you can log both sides. Now this is where the mathematical knowledge is required.
Yeah, so what doing logs both sides will do is it will get rid of our 10, or
Yeah.
2 to the 14 at least, and put it as just equals minus 14.
It will indeed. Now when you take logs of products like this,
Mhm.
it's the same as saying the log of the first thing.
Added to the log of the second thing.
Yes, so it becomes this.
It does, and it equals minus 14.
Yeah, we've got rid of the 10 to the power.
But pHs aren't negative values.
They're not. So I don't like this minus 14.
No, so
We
times
times everything by minus 1.
Yeah, precisely that. We get minus log of H plus, minus log of H minus, and positive 14.
You do indeed.
Remembering what pH is, it is minus log of H plus.
So this whole thing can be replaced with pH, which
Yeah.
is what we're trying to find out.
It is.
And this minus log OH to the minus,
Mhm.
OH minus, sorry, can be taken over the other side.
Yeah, so what
we
you get is pH is
14
equal to 14. Add this.
log.
But adding log
H
of
minus.
0.05 is actually a negative number.
Yeah, if you type it into your calculator, it actually becomes minus 1.3.
Yeah, which is what we did there, but much quicker, and I give you the pH.
So that's why it works.
Mm-hmm.
Now, if you don't understand that, don't worry. If you did understand it, that's good, you can understand it.
Yeah, and then you have 2 methods to choose from.
Examiners' reports say that people more commonly get it right when they use the first method.
Sometimes they slip up on this one, so whatever you're more comfortable with, I think.
Yeah, whichever you're more comfortable with. This one's nice, it's quicker, it's easier, and if you understand it, I think you won't have any problem with it. But
Mhm.
sometimes things can be a bit dodgy.
Yeah.
And that's finding out the pH of bases, if you ever wanted to do that, ever. Maybe.
Yeah, just in life, you look at some mineral water and go, I wonder.
Yeah, maybe you do. In
Maybe
which
you do.
case, there you go, you can impress your friends.
Yeah,
That's good.
that's good.
Next, we're on to buffer solutions, we'll see you there.
Alright.